There's one special frequency where an inductor and a capacitor completely cancel each other out. It's called resonance. At that frequency, the current can spike, the voltage can climb far above the source, and the circuit suddenly acts like there's nothing there but the resistor. It's how a radio picks one station out of the air. Let's see how it works. Remember the two reactances. Inductive reactance, XL, equals 2 pi FL. It rises as the frequency goes up. Capacitive reactance, XC, equals 1 over 2 pi FC. It falls as the frequency goes up, and they push in opposite directions. In a series circuit, the net reactance is XL minus XC. So picture sweeping the frequency. Down low, XC is huge and XL is tiny. Up high, it flips. XL is huge and XC is tiny. Somewhere in the middle, the two lines cross. At that one frequency, XL exactly equals XC. That crossing point is resonance. And when XL equals XC, they cancel. The net reactance is 0. With the reactance gone, the impedance drops to just the resistance. Z equals R, its lowest possible value. And Ohm's law does the rest. Low impedance means the current jumps to its maximum. I equals V over R. The circuit is now purely resistive. Voltage and current are back in step, so the power factor is 1. So at resonance, the circuit is wide open at that one frequency and choked everywhere else. That's what makes it a tuner. Now, the frequency itself. Set XL equal to XC, solve, and you get the resonant frequency. F0 equals 1 over 2 pi times the square root of L times C. Just the coil and the capacitor said it. Let's put numbers on it. A 1 Henry coil and a 1 microfarad capacitor. F0 equals 1 over 2 pi times the square root of 1 times 1 millionth. That works out to about 159 hertz. Check it. At that frequency, XL is 2 pi times 159 times 1. About 1,000 ohms. And XC comes out to the same 1,000 ohms. They match. They cancel. So if the resistor is 100 ohms, the impedance at resonance is just 100 ohms. Here's the part that surprises people. The reactances cancel each other, but each one is still there. That 1,000 ohm reactance carrying the full resonant current puts a big voltage across the coil and across the capacitor. It can be many times the source voltage. That multiplier is the Q factor, the reactance divided by the resistance. A high Q makes a sharp, selective tuner, but also a serious voltage rise. So that's resonance. XL equals XC, they cancel. Impedance bottoms out, the current peaks, and F0 equals 1 over 2 pi root LC. It's the heart of every radio, filter, and oscillator. Next time, back to the board, grab a pencil, and I'll see you there.